Advent of Code 2024, day 11, Plutonian Pebbles. So I'm going to get a list of numbers, and they are representing stones, the numbers that are engraved on stones. And every time I blink, each stone is replaced by one or two stones in the same order. So they stay in their perfectly straight line. And I need to blink 25 times. So the rules are, if a stone has a 0, it gets a 1. If it's engraved with an even number of digits, it gets replaced by two stones, the first half of the split on the length of the string. So like 1,000 becomes 10 and 0, where this leading 0 is dropped. Otherwise, we multiply by 10, 20, 24. The order is preserved. They say that's important. And so, here this is probably our example input. The 125 gets multiplied by 2024. The 17 becomes 1 and 7. This one splits into 253 and 0, and then this becomes 124, and this one becomes multiplied by 124. So as we blink, the list is going to grow. We'll see blinking 6 times, I get 22 stones. After 25 times, I get 55,000 stones. So this is going to grow pretty exponentially. So the question is, how many will happen after 25 blinks? Little strategy conversation here. I'm noticing that the order, the order is preserved in a perfectly straight line, but for part 1 it doesn't matter, right? Because we're just trying to get the length of the list, and once a stone, once this 1 and 7 split, like if this 7 were over here, they never interact with each other. In fact, it just seems each stone independently moves on. So I don't know what's going to happen in part 2, and that's a little bit. I'm hesitant to close off a lot of doors. But it's some twist is coming in part 2. It could just be that we blink more times, which will require a more efficient solution. But like, it's also possible that now we have to interact with the ones next to us and something. So I don't want to lose that in my part 1 work. So let's go ahead and jump in. I'm gonna start with my GenDay script for day 11. This pulls my input and creates me a stub. I will create an ex.txt as well with that. I believe I need the new line there. There's a new line on this one. I want it to look the same. The input, it's not that long. It's 1, 2, 3, 4, 5, 6, 7, 8 numbers. But again, it's going to grow fast, I think. So, all right, let's open up. I'm going to do stones equals, and so I'm going to do f.read. I'm going to strip off any white space on either side. I'm going to split button space, which by default I don't have to specify, but I like to specify. I think that just looks nicer to be explicit. So now I've got a list of strings. I want to apply the integer function to each of them, so I will map int like that, and then the map returns a generator, so I need to make that into a list, and I will do that like that. Now I have a list of ints that will be my input. All right, for part 1, I think we're just gonna follow the rules. Where's the rules? Let me grab them here and put them here. Comment that out. Can Alt Z will word wrap for me. So we're gonna say for underscore in 25 in range 25 times. What are we gonna do? We'll say new stones equals a list. We can say for stone in stones, if stone equals 0, then new stones dot append 1. That's the first rule. Next one is the length of the digits. So we'll say elif len string stone mod 2 is equal to 0. So if it's even, then what are we going to do? We're going to get new stones dot append, and we need to get both halves. So that's going to be string. I should probably make this a variable at some point. String stone from here to here. Let's see, and it's going to be like this. It's going to be len string stone divided by 2. I think I just need to do that, and then this will be here. I think that looks right. Let's see. Wait, I think len string stone, this should be here. And then this should be like that. Fix that here too. Len of the string of stone divided by 2. This one comes after, this one comes before. In fact, I think I just messed up the order. This is actually supposed to go here. So I get the first half of the string, the second half of the string, and I need to int that, but turn it back to an int. We can make this prettier. We will come back and make this prettier. Otherwise, we will say else new stone append stone times 2024. And I mean, we could have just solved it. Len stones. Oh wait, I need to definitely need to. Oops. After I do my stone, after I do all my stones, I say stones equals new stones. Otherwise, that will go forever, or otherwise it will never change. So now, if I do Python day 11 example 55 that sounds very familiar. Yeah. Let's see. Can we do our input? We got something. Sweet. All right. No twist. I don't even need to pause the video. Let's see. To be fair, infinite quarters are very large. How many stones will blink after 75 times? So I'm assuming, fair to assume, that changing this to 75 will slow down. I can't even do my example. Let's see. What if we do a print I comma len stones? So it starts slowing down right after 25, it seems, because we're getting much larger lists here. We're in 5 million now, 8 million, 112 million, etc. Okay, so that's where it's going to take a long time. Probably not possible. Okay, let's make this go back to there. So that was all instant. I'm basically going to think I think we have to throw this away. But I think we already made the key observation, and that is that a stone does not have any impact. The stones don't have any impact on each other. So if I can look at a stone and how many steps are left, I can give you the count. So I guess we're just going to comment you out as well. And well, let's see. We'll see if we can solve part 1 the more efficient way, and then we'll just do part 2. It'll be easy. So we'll do. This is important. We're going to need a cache. So we're going to say from functools import cache. And what cache is going to do is I can decorate a function. Let's see. Def count stones. And it's going to take in a value and a number of blinks. And it's going to, let's see, actually, I can int. Okay, and it's going to return, let's just for now say 0 because I don't, let's just say return val. I'm just making something up right here. Find blinks. If I come in here and say at cache, what this is going to do is, what's the easiest way to show this? I know, okay, here, I can do print calculating answer. If I run this right now, I don't think it's going to do anything. It's not. I'm going to put a -I in here so I can get a terminal afterwards. If I run this right now, I don't even know where that came from. Oh, it's my input. Okay, if I run this right now at terminal left. So if I do count stones of 1, 2, 1, 3, I get 3. And if I do this again and again and again, I get there. Now, if I come in here and do cache and decorate this with the cache decorator, and I run it again, and now you'll notice it's not printing calculating answer, because what it's doing is it's basically wrapping this function. So what a decorator does is it takes this function actually is called with these arguments, and it said it can do some stuff and then calls this function. So what this is doing is actually caching the result. So if the result is 1, 3, it just says, oh, I know the result is 3. I'm just going to save that. I'm not going to bother doing this calculation again. I'm just going to return it. But if it's something I haven't cached before, I'll call this function, get the answer, cache it, and then return that answer as well. So what that means is if I say, if I have, so now we can do a recursive function that counts, returns a count. So let's take a look here. If blinks equals 0, if there's no blinks left, then we're going to return 1 because that's our base case, right? We're done blinking. We're done with the stone. We're returning 1. If now our val is equal to 0, return, then we're going to return count stones where with a val of 1 and a blinks minus 1. So we're going to have 1 less blink, and we're going to just return, we're just going to turn our stone into a 1 and return that. If, let's see, we need to do the same thing here. So I'm going to do, now so we've already returned. So we can say string val equal string val. I'm going to say len string val, it's probably better ways, equals len string val. So now we can say if len string val mod 2 is equal to 0, so if it's even, we're going to return count stones of string val of first, we want from here to len string val over 2 blinks minus 1 plus, and we just need this whole thing again. And this will be over here. And then here we just do a return count stones val times 2024 blink minus 1. So now, in theory here, we should be able to do count stones, the val, okay, we need to do each stone. So we do sum s for s in stones. We'll loop over all our stones. We'll get the count stones of there, and we'll blink 25 times. And so in theory, all we've done is completely rewritten part 1. And we have a memory error. Let's see. Let's count stones on stone. We are shrinking our blinks each time. Let's do print val. Oh wait, did I? Okay, val, comma blinks. Man, my computer got real. I guess let me get rid of this mash I because I don't. That's probably. I am clearly. Let's see. Oh shoot! I'm passing strings in here. I got to make these ints. That's why I'm getting these long strings. Int string val like that. I bet that's it right there. That was very fast. Let's get rid of this print because it's making it messy, and I don't like it messy. But we have our right answer. We're back to part 1. 198.075. Yep. Okay. So the question is now. This will be very easy if we can just do boom and make this 75. I don't think they gave us an example. They didn't. They just said do it. So we'll skip our example, but it runs very quickly, and it worked. So noticing right away that the order didn't matter was really the key there. And then thinking about how, just thinking, you have to think through, okay, what is my actual challenge here is to take each stone and figure out how many stones it turns into. And it doesn't, that can work recursively with cache really nicely. Caching, of all the tools you learn in Advent of Code, like you want to learn a breadth first search, you want to remember how to cache, do recursive caching. I'm sure there's others, but those are the ones that jump out to me immediately. So, all right. Day 11 in the books. We'll be back tomorrow. Talk to you then. Bye.